So today we're going to talk about similar solids and k squared, and k cubed, how to use k squared and k cubed. So basically, let's say I have two similar cones, and what does it mean to be similar? It means that proportionally this height over this height is equal to this radius over this radius. So essentially it's just a bigger or smaller version of the same cube, same cone, sorry. So it wouldn't be like a longer cone. It wouldn't be, it could be upside down. You could say this is still similar to that. This is still similar. But if you stretch it, which I'm not really sure how to do, it's not letting me stretch it. But if you were to somehow stretch it into a cone that looked, something like, or like a fat cone where it'd be like the very low height. That's very badly drawn, but you get my point. It doesn't even look the same because this has a very different proportion. This is a very long base to a short height. So you could say this proportion, this over this, height over radius, will equal height over radius here on both of them. This height over this radius will equal this height over this radius. So then, once you establish it, these two are similar solids. So I'm going to get rid of all this. Once you establish that these are similar, basically a bigger, smaller version, and it's proportional, their sides, you can basically say, well, big H, which is this big height here, over small h is equal to k, and k is just some constant in this case. Now it becomes a constant. It's just a letter that we call the ratio between the bigger height over the smaller height, so this could be k. You could also say that this is k. The cool thing is, so it's either big over small or small over big, so now you have k. The cool thing is that if you square this, what you need to do is square this relationship, and you get, if you square k, so you get k squared is now equal to the relationship between, it's what you need to multiply by to get this to this in anything in the second dimension. So for all areas, surface area, lateral area, so the lateral area of this times k squared equals this, equals the lateral area of this. So once again, I'll write that again, the lateral, switch up the colors, the lateral area of this guy multiplied by k squared is equal to the lateral area of this guy, because it's an area. And the trick to knowing whether you use k squared, or k cubed, is look at the units that you want your answer to be in. So if it says, what's the area? Areas come in centimeters squared. So use that. If it says, find the volume, that comes in centimeters cubed or meters cubed, well, that's cubed. So let's actually do a problem with two cones. So you would get like, here's a cone, here's another cone, the height of one is 4, and the height of the other. So you'd say, well, the height here is 9, the height here, we'll say the height here is 3, and the height here is 2. And then we're just going to say, well, this has a lateral area of 40 centimeters squared, and it also has an area of, a volume of 30 centimeters cubed. So obviously what you can do is you can say, well, I'm going to find the radius, and I'm going to go this whole long way, divide by 3, or find the circumference, the perimeter. If you know how to find the lateral area of a cube, go backwards, work backwards, and do all this work. But also what you can do is just say, well, K is equal to 3 over 2, or 2 over 3. But we're going to say 3 over 2, which is big over small. It's important to know if you're doing big over small or small over big, because later on that will matter, whether you multiply or divide. So we're doing big over small. So K is equal to 3 over 2. Now, if it says the lateral area of this is this, and it asks you what the lateral area of this, the temptation would be, well, to say, well, 40 divided by 3 over 2, which is 1.5. But you can't, because they're not in the same. That is wrong. What you need to do is get your K squared, which is square the top, 9, square the bottom, 4. And now you can do 40 divided by 9 over 4, which is like, dividing by 9 over 4 is like multiplying by 4 and dividing by 9. Right? And that would be your new lateral area. And your volume, you use K cubed, which would be 3 cubed, which is 27 over 8, 2 cubed. And now you would say, you would divide 30 by 27 over 8, which is like multiplying by 8 over 27. It's like you're flipping it. That's what you learn, how to divide fractions. And this would be your volume. I'm sorry, I'm pretty messy in this lesson. But how do you know to divide? How do you know to multiply? Some people ask. Well, this is because it's big over small. So if you have, let's extend this page, your ratio is big over small. And you have big volume. So how do you find small volume? This is height. So you have the big height over the small height, and now you have big volume over, and you have small volume. So what are you going to do if you have this one? Why do you divide or multiply? The question is, you just go big volume, and you divide by big height over small height, and that is technically like multiplying by this. Oops, sorry, that is technically, if you divide, you're not multiplying by this, so that's actually like doing small height over big height, and this equals the small volume. So what you're doing is, if you were to move this up, you're basically creating like this proportion here, where the big volume times the small height equals the big height times the small volume, which does make sense. Think back and try to think back to what I said. It may have been a little complicated. I may not have done the best job explaining also. So